Go to TAPgiles.com to learn dreams, engage my services, and support the channel. Now I'll show how to make this thing, which is the interesting part. So the basic idea is, it's just like the built-in normal stick movement, which is when you push up, you want to move away from the camera, down you want to move towards the camera, left you want to go left to the camera, and right you want to go right to the camera. And then you kind of multiply, if you're pushing up on the stick, then you'll get a positive number, and you'll multiply how away from the camera you want to be by that, so that you move in that direction. And if you push down, it will be negative and pull you towards the camera. Things like that. So first we need to get directions for forward and right of the camera, for example. So if we use a head or camera tracker, and then this is just like a special group and it follows the camera. So we'll have a chip in here, and we'll have a node coming in. And this actually has outputs in the tweak menu of these different directions. So Z is forwards, for example. So let's wire that in there. So we've got the forward direction. We want to multiply that by how up we are pushing on the controller. So this is forwards, and we want to get that stick value out from the controller sensor. So I'll put this into remote controllable because the puppet is going to be running around. We don't want to have to possess this object as well. It won't work. So we'll have this be remote controllable. And in the third tab, you have left stick local. And that is just purely up, down, left and right on the left stick. Cool, let's get a splitter and wire the left stick into that. So this has multiple values coming through it, which means you can get these out by using a splitter. And now we have a left and right value and an up and down value. And it will be positive when we're going right, and negative when we're going left, and positive when we're going up, and negative when we're going down. So let's just multiply this forward direction with a calculator by how much we're pushing up. And then we want to convert it into a stick value, because this works a bit differently. You can see here there are two colors braided in, and there are two values you get out the other side. This has three colors going through it, and if we use a splitter, there are actually three values. So there are actually like these different kinds of fat wire. So we want to convert this into this, and that's fairly easy. We just take that thing that we got there, and then we use a combiner of this kind of fat wire. So if we tweak it, we have all these types, and one of them is left and right stick. And now we have the X and Y, and we can just send it in whatever value we want, and then send the result into the walk of the puppet. So you could have this generated in any way you want. You could have value sliders that are animated doing different things to control the character. Something to understand about a stick value is when you're telling a puppet walk interface thing over here, when you're sending a value into here, then X is the X of the scene, and the Y is actually the Z of the scene, going forwards and backwards like that. So we want to send it those same values from this process direction we got. This is actually, so this direction is like a 3D thing pointing in a direction in the scene. So there are three values, X, Y, and Z, but they could be, this is just a generic 3-number fat wire. So it could be representing anything. But we know that they're in the same order, X, Y, and Z. So we need X to go into X and the Z to go into the Y, so that matches. Cool. So now if we go into here and I push up, it's going in that direction. If I push up, it's going in that direction, all depending on which way we're pointing. So it's working exactly the same as the normal camera relative stick. And if we push down, it's moving towards the camera. But left and right won't do anything yet. But if we go left and slightly forwards, we go just a little bit forwards, for example. So now we'll just do the same thing for left and right. So basically we're making our own camera relative stick control. But the point of this is to be able to pause it and freeze the orientation of it when we want to. So we multiply it by those things, and then we need to add them together to get the left and right and up and down of that. Cool, and then wire the X, which is the right direction relative to the camera. So now let's do that and see what we get. So right and left is relative to the camera, and basically it works exactly the same as the normal camera. The only thing is, if we look kind of down like this, then up and down will be very slow. And if you think about it, it makes sense. If we have a camera and it's pointing down like that, so the forward angle will be like that from the camera's point of view, like that, which means this is a 3D direction. So we've got like some negative Y, but we're ignoring all that because the stick only uses left and right and up and down. And then we've got a tiny bit of forwards, and maybe if this was tilted, to the side a bit, we'd have a tiny bit of left and right. The length of this kind of direction thing value is the same no matter what direction it's pointing in. But if we're pointing down and we're ignoring this Y part, then it's like it's actually pointing like we're getting a tiny little arrow that's ignoring all the Y, and it's just like forward a bit and left a bit. So everything gets really slow. So we want to kind of normalize this and make this, we take this direction and then we make it the same length as it was for the normal full direction. This is known as normalizing. It means you take any kind of position or vector or direction and you make it of length 1. So no matter what direction it's pointing in, it's always the same length, and then it will always have the same effect. So that's what we want to do in here. For that though, first we have to change the order this is working in. We have to make it into this 2D thing first, and then we can normalize that and then add them together. So let's copy this over here, wire that in there. And we want to find the how long this already is, so we can kind of compensate for it. To do that, we can use a combiner in the default signal mode and wire it into the plus. So this is still a fat wire. All fat wires have a default value, which is calculated in various ways depending on what type it is. For vectors and directions and positions like this, it is the distance from 0. It's the length of the direction itself of the values. So if we do this, we get that out of here. And then we want to divide this by its old length, and that will set the length to 1. I won't go into the mathematics of it right now, but it does the thing. So do that. Cool. And then we multiply it. So we won't need that or that. And then we add it to the other one. So we need the same things happen for this up here. Like that. And now this is turned into a stick value already down here. So we can just take that stick value and put it into the walk. And that should just work. So if you look down, we still get the full speed going forwards and backwards and left and right. Cool. Lastly, we just want to be able to lock, and we're going to use that now. So we want to lock this while we're pushing the stick. So first, when are we pushing the stick? Let's use the combiner to do that same trick and put the left stick local into it. And now this will output how much we're pushing the stick. So if I use a displayer, play time. Now, as I push the stick more and more, if I'm like down here, you can tell how much I'm pushing it. So as I push the stick more and more, it's becoming a larger value. Even if I'm pushing it in a different direction, it doesn't matter. It's just purely how far I'm pushing the stick. So now we can say if we're pushing the stick more than 0, so if we're pushing it at all, then we want to freeze these things so that the orientation is locked in. So to freeze these values, we can use a signal manipulator. So if I just demonstrate what's going on with this, let's get a value slider, and one for output. So it just takes in a value and manipulates the value and then spits out the value. So if we set it to 0.8, it's just giving us the 0.8. But it has this setting called freeze output, and whatever it's outputting at the time, so 0.8, it won't change that while this is frozen. So now the input can change and the output doesn't care. And then when we unfreeze it, now it will be back to whatever it's receiving into it. So we'll do that, but for the actual orientation down here. So let's put that in there, and that in there. Move this around a bit. Do the same up there. And now it will still work the same, it will just be a normal camera relative stick thing going on. But we want to turn on freeze for both of these, like that. So while this keyframe is powered, those outputs are frozen, so it will still let you move around and multiply the result, but it won't change the orientation. So while we're pushing the stick, we'll lock that in. So I can still push forwards and back and left and right, but if I push forwards and change the camera angle, and I'm still holding up, then it's just locking it in while I'm still pushing the stick. So I can look over here, now I'll push left. Now we're going towards the camera, and things like that. And then when we let go, and then I'll push up again, now it's going in that new direction, and then up again, and new direction, and that's exactly how we want it to work. So let's put them back around here, and turn that camera on again. So now we can move like as normal around here, and then when we push right when we're over here, and I'll keep on pushing right, we're still moving in that same direction in the room. And then we let go, and now I'll push right again, and now we're looking right, moving right according to the new camera angle. And if I come out and I keep on holding down, it'll keep moving in the same direction in the scene. And now I'll push down again, and I'm moving towards the camera. And that's about it. The rest is kind of bells and whistles. You can like try and optimize this, make it work in a different way, or just use the object that I've made and release.
Thanks for watching. I hope you learned something interesting. Go to patreon.com/TAPgiles to learn something new every day.